Hi everyone, it's Orkan. Today we have a problem when we are given an array of nums and an integer k, and then we need to find out whether or not it's possible to divide this array into a subsets where each subset sum is equal. For example, in this case, for this scenario, we have 5, 1 plus 4, and 2 plus 3 and 2 plus 3. Sum of each gives us 5, and in this case we are returning true. And for this scenario 1, 2, 3, 4, we have k is equals to 3. So in this case we cannot form a k3 subsets where sum is equal, sum of the subsets are equal. So in this case we are returning false. Let's take a look at this example one more time. So in this example, we can partition our input array to k subsets. In this case, k is equals to 4, that are the sum of which are equal. So let's define our steps. What would be our first step in this case? Our first step is that the sum of our all elements in the input array, that should be divisible by k. If sum modulo k doesn't equal to 0, so it means that we cannot divide doesn't matter which subset we will take, we cannot divide our input array to k subsets. So that's our first step. So our first step is check if sum is divisible by k. If it is, we are proceeding further. If not, then we are returning false right away. What would be our second step? Our second step is we need to define our target. Is a target number. For example, in this case, the target is 5, and our each subset should be equal to target. So target is simply sum divided by k. So the second step is define the target number, which is the sum divided by k. And after that, we are proceeding to third step. Third step is we need to find all possible combinations, right? All possible subsets. That is giving us we need to find all possible subsets, and we need to select from those subsets those that are giving us those subsets that the sum of which is equals to our target. So to do that, but we cannot use the same index, same value twice. So for that, we are creating an array of Boolean, and if we are using any element, we are setting those values to true in our array of Boolean. So for now, for the starting, we are setting all the values in the array of Boolean. We are setting that to false. And also we are defining our two variables. The first variable is the target, and the target is equals to 5, for example, in our example, right? And also we are defining our next variable, which is a current sum. Current sum is equals to 0, but as we are progressing, as we are generating all possible subsets, we are adding that value to current sum. And if the current sum is equals to target, it means that we found the subset we found one subset. So for example, we are starting with the 0 index, with the 4, and we are setting that value to true. And we are starting with the 4, and we are adding the value to current sum. And now we are generating all possible scenarios. So that we are starting first with the 3. So 4 plus 3 gives us 7. So 7 is more than our target value. So we are backtracking. We're actually not even exploring that option because 4 plus 3 is more than 5. So we are moving to the next one. Next one is 4 plus 2. 4 plus 2, again, it's more than our target. We are moving to next one. 4 plus 3, again, more than our target. 4 plus 5 is more than our target. 4 plus 2 is more than our target. And the last one is 4 plus 1 is equals to 5. It's exactly equals to our target. So it means that at this point we found our first subset. Our first subset is 4 and 1, and we are setting the value for k. We are decreasing the value because it was 4. Now we need to find the 3 subsets, and now we set in our array of Boolean, we set the first index 1 and the last one to true, because that forms our first subset and we cannot use those values. Now let's go to the next one. Again, we are again starting to generate our tree one more time, starting from the beginning, but we cannot use first index, and we are setting our current sum to equals to 0 because we are looking for the new subset. We cannot use the first one because we already used that. We are starting from the second one. We are starting from 3, and the 3 plus, so we are going and generating all possible scenarios again. 3 plus 2 gives us 5. 5 is exactly equals to 5. So we found our second subset, and we are again subtracting from K1 because now we need to find two subsets, right? And we are setting the values to true for the first index and for the second index. And now again, we are setting our current sum to 0, and we are starting to generate our tree one more time. So we cannot use 0 index, we cannot use 4, we cannot use first index, second index. We are starting from our third index, from 3. Again, we are adding that to our current sum. So 3 plus 5 gives us 8. We cannot use that. 3 plus 2 is exactly equals to our target sum. So again, now our k is equals to 1. And now again, we are starting over, and we can use only 5, right? And the 5 is equals exactly to our target sum. Now our k is equals to 0. K is equals to 0. At this point, we can return true because we have found all the subsets. We found all the subsets that is sum of which gives us our target. So our subsets are 5, 1, 4, 2, 3, and the 2, 3. And what's the time complexity of this solution? The time complexity is, since we are using a backtracking, in the worst case, it's exponential. It's a 2 to the power of n. How about the space complexity? Space complexity is determined by we are using only one data structure here. We are using additional, which is our array of Boolean, and it's the size of n, so size of our input array. So our space complexity in this case would be of n. Okay, first thing that we do here, we are calculating the sum of all elements in our array. And if we are taking the modulo, if the modulo is not equals to 0, so it means that we cannot form k subsets, right? So we are returning false right away. If we can, then we are proceeding, and that we are finding our target. Our target is equals to sum divided by k. So for example, in our case, sum is equals to 20. 20 divided by 4 gives us 5. That's our target. Also, we are creating array of Boolean, which is the size of our input array. And then we are calling our backtracking method in order to find the all subsets. So we are passing here our nums, our visited array, and also we are passing here the starting index, from which index in the array we are starting, and also we are passing k, our number of the subsets, and we are passing our current sum, and we are passing our target. So what's our first base case? The first base case is that if our k is equals to 0, it means that we are returning true. We found all the possible all subsets. The next one is if our current sum equals to target, so it means that we are, again, as in our example, right, we have seen earlier, so we are starting over again, and we are finding for another subset. It means that we found already one subset. Since we found already one subset, we are starting again. We are starting from the beginning, and we are setting our current sum to 0, but we are subtracting from our k, right, because we found already one subset. And the next one is our for loop, where we are starting, what we are checking. So we are starting from the first index, or whatever the start is, right? So we are starting from there, and first we are checking if we have visited that. If we haven't visited that, that's the first condition. And if our current sum plus num I, if that is less than or equal to target. If that is more than, for example, in our case, as we have seen earlier, if 4 plus 3, right? So in that case, there is no reason to proceed, so we are just keeping that scenario. And the next one is that we are checking that once this condition is met, we are setting our visited to true, and we are again recursively calling our backtracking method and generated all possible scenarios. Once we found all subsets, so we are returning true. And as let's say that we started for the 0 index and we are backtracking, right? So then we are going to go to the next index. So we are setting our visitor to false because we are going to use that. We haven't used that index. It means that we haven't. So that we set that index to true, but we haven't found any subsets for that. So we are setting that back to false as we are backtracking. And if we haven't found subsets that are equal to, after exiting this loop, if we haven't found subsets that are equal to k, that the k subsets, sum of which equal to our target, then in that case, we are returning false. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.